So in today's wrap lesson, we're going to be talking about angles and polygons. The first four problems are all about angles and triangles. And I'm actually going to do problem 1 and 3 with you and then have you try problem 2 and 4 on your own. And then we'll go back on the back half of the paper and look at polygons back there. Starting with number 1. This is the type of problem where we want to make the list. So we're going to make a list of 1 through 8. So angle 1, 2, 3, 4, 5, 6, 7, 8. Starting specifically with angle 8, you'll notice that there's no angle 8 in the drawing. I'm going to number the given angle, which is 107 degrees, as angle number 8. That way it just has a number that we can kind of refer to. Now we need to go through and find the remainder of the other angles. Because angle 8 is 107 degrees, I also know that angle 3 is 107 degrees because it is vertical to angle 8. Make sure when you're writing your reasons that you mention what angle it is vertical to. So angle 3 is 107 degrees. Angle 2 is going to be 73 degrees because it is supplementary to angle 8. Supplementary means it equals 180. Angle 1, I got to write, unfortunately, right over top the drawing, 73 degrees, because it is vertical to angle 2. Now we need to jump from the top half of the drawing, or the figure, down to the bottom half. And to do that, we're going to use the angle property of corresponding. Angle 4 corresponds with angle 8. So because of that, we know that angle 4 is also 107 degrees. Because angle 4 is 107 degrees, we know that angle 7 is 107 degrees because it is vertical from angle 4. Angle 5 is 73 degrees. Lots of reasons we know that angle 5 is 73 degrees. I'm going to put that it corresponds to angle 1, which is true. You could also put that it is alternate interior to angle 2. And it is also supplementary to 7, so any of those reasons would work just fine. That leaves angle 6. Angle 6 is 73 degrees because it is vertical from angle 5. You're just making a list, describing what the measurements are and kind of why. For 3, unfortunately my picture disappeared, so I'm going to go ahead and draw one. I think it looked down a little bit, something like this. And I'm being asked to find x. In order to find x, I need to find this missing angle right here, and I'm going to call it y. The 46 and the y are supplementary angles. So if I take 180 minus the 46, I'm going to figure out what y is. So I end up with 134 equaling y. So y is 134. We know that inside a triangle, all 3 angles in a triangle must always add up to 180 degrees. So 134 plus 31 plus x needs to give me 180 degrees. Combine together my like terms, 165 plus x needs to give me 180. Subtract or add negative 165 to each side. And we find out that x is 15. At this point, I'm going to ask the teacher to pause the video. I'd like you to go through and try problems 2 and 3, please. Now that you have had some time to try problems 2 and 4, we're going to go ahead and look at those. Problem 2, you actually want to start by trying to figure out the measure of all the angles. Don't worry about the math-looking problem right now. Take the 45, that's down here, and try to label as many things as you can. Because of that 45, we know 6 is 45 because it's vertical. We know that 3 is 45 because it corresponds. We know that 2 is 45 because it is vertical from angle 3. We are then able to determine that 8 is going to be 135 degrees because 45 and 135 have to add up to 180 degrees or supplementary. So angle 5 is 135, angle 1 is 135 because it corresponds to angle 5, and the math problem has to equal 135 because it is vertical from angle 1. So now we know that this math problem, 5x plus 35, has to equal 135. That's what the measurement of that angle is. The problem wasn't asking what's the measurement of the angle, it's asking what x is. But we need this angle measurement in order to figure that out. Solve a pretty basic two-step equation. Add negative 35 to each side. We get 5x equaling 100. Divide by 5. X is 20. Problem 4. My triangle, I believe, is actually way up here. Kind of doing the same thing we did in the other triangle problem. We have y. I know that 180 minus 92 needs to give me y. So 88 equals y. And then 50 plus 88 plus x needs to equal 180. That's going to give me 135 plus x equaling 180. Subtract or add negative 135 to each side. And I get x equaling 42 degrees. So now we're going to go ahead, we're going to flip, or not polynomials, polygons now. And the main formula we're going to use with polygons is 180 times n minus 2, where n is my number of sides. So in the first problem, I want one interior and one exterior angle for a hexagon. We know that a hexagon has 6 sides. So 180 times 6 minus 2 is 180 times 4. So I know the total degrees in a hexagon is 720. That's not one of my answers. I need an interior and exterior angle, but I have to find the total in order to get to the interior and exterior angles. My interior angle is always the total divided by the number of sides. So it's going to be 720 divided by 6. Which gives me 120 degrees as my interior angle. My exterior angle is always 180 minus the interior, because my exterior and my interior angle together have to equal 180 degrees. They're supplementary angles. So 180 minus my interior, which was 120, tells me that my exterior is 60 degrees. At this point, I'm going to ask the teacher to go ahead and stop the video, or pause the video, have you complete the rest of the problems, and then I will come back on and we'll go over them. So now we're going to look at a decagon. Decagon has 10 sides. So that's 180 times 10 minus 2. 180 times 8, and I get my total to be 1,440. To get my interior angle, I take that 1,440, I divide it by the number of sides, which is 10, and my interior angle is 144 degrees. My exterior angle, I take 180 minus my interior, which is 144, and I get my exterior angle to be 36 degrees. Same process for a 15agon. 180 times 15 minus 2, 180 times 13, that gives me 2,340. So my interior angle is 2,340 divided by 15, so 156 degrees for my interior angle. My exterior angle is 180 minus 156, so my exterior angle is 24 degrees. Now I want to find the measure of each angle in a pentagon. Basically, it's asking you for what is one interior angle. It's just rewording the problem differently. So I need to find the total again first. So 180 times n minus 2, so that's 180 times 5 minus 2. 180 times 3 gives me a total of 540. I need to divide that by the 5 sides on each pentagon, and I get one angle to be 108 degrees. In problem 9, we're going to work backwards. We still have the 180 times n minus 2. This time, though, we know the total worked out to be 900. We're going to divide each side by 180, and that leaves me with n minus 2 equaling 5, plus negative 2, add 2 to each side, and n is 7, which is a heptagon. For 10, there's really two different ways you can do it. Personally, I like to draw a picture, quadrilateral. When someone mentions quadrilateral to me, I immediately think of like a square or a rectangle. Two of my sides are 80. On a quadrilateral, opposite sides have to have the same measure. So if you put one side being 80, the opposite side has to have the same measurement. That leaves this side being 100 and this side x. Well, now that I have the picture, I can clearly see that x would be 100 degrees. The other way you could go about this is 100 plus 80 plus 80 plus x needs to equal the total of a quadrilateral, which you should know is 360. So 260 when I add up my like terms plus x equals 360. Subtract or add negative 260 to each side, and I get x equaling 100. So no matter what way you do it, you still end up with the same answer. You still do have to show work, whether it's the picture that you're using to show work or whether it's the actual math equation. But either way, you have to show work. So that wraps up our lesson on angles and polygons. If you have questions on anything that we've gone over, please feel free to stop by and see me.